Let's look at the moment of a force. Now, when I'm talking about moment of a force, is simply the turning effect of a force. That is what we refer to as moment. So, the turning effect of a force is called the moment of a force. The other word for moment of a force or the turning effect of a force is called torque. When you're talking about these forces, we can measure the moment of a force if we know the magnitude of the force applied and also the perpendicular distance. So if you have got, say you have got this is a ruler and then you put it on a certain point, okay, like this. So if you know the force that you is, let's say you've put a mass here, you've put a block at this point. Because of this block, you can see it is going to give a force to this object like that. Okay, this force will be pulling this ruler downwards, and you need to know this distance from the pivot. So a pivot is very important here. So this is the distance x and this is the force. Now you can see these two are making 90 degrees to each other, so the force and the distance should always make 90 degrees to each other. And the moment of a force or the turning effect of a force, the formula is going to be just moment is given by force multiplied by the distance. The force is given in newtons, the distance is given in meters. So this is the unit for moment of a force, newton meter. Okay, the other thing that you need to know is that force is also given as what? Force is the same as weight, and weight is given by mass times gravity. Okay, so you might find that the unit is also in mass. We know that it is given in kg, gravity is given in meter per second squared. So where there was force gives us a newton, and the newton is the same as kg meter per second squared, and then multiplied by this meter again. Okay, so we're going to say that the unit for force, I mean the unit for moment, can be also kg. This meter will multiply with this meter, that will give us meter squared. So it will be kg meter squared per second squared. This is also the unit for moment of a force, which is the same as newton meter. So this is the formula as we've said. Now we have got what we call the principle of moments. And when you're talking about the principle of moment, it just says the clockwise moments is equal to the anti-clockwise moments. If you have got forces which are taking something in this direction, they should be equal to the forces which are taking something in this direction if that thing is not moving. Okay, if it is not moving, but if it is moving, well, this might not be true. The principle of moments works for something that is not moving. For example, we are going to use this same object like this. Okay, let's say we've got a ruler that you've put like that, you've put it on a pivot, and then we've put one object here, we've put also another object here, and then we have got a distance from the center, from the pivot to this object like that. Let's call this one as distance 1, and then this distance here as distance 2. Let's say this is going to have a weight, and that weight is giving us a force 1. This one also of course is going to have a weight that is going to give us a force 2. So if this thing is not moving down in this direction, that means it's not coming like this, and it's not moving also like this. If it is just balanced the way we are able to see it like here, then the principle of moment is going to work. That means if we multiply the moment, the clockwise moment should be equal to the anti-clockwise moment. Clockwise is going in this direction where a clock moves, so the clockwise moment is this one. And then when this force is greater, this thing will be able to go down like that. That's the anti-clockwise moment. So d1 multiplied by f1 should be the same as d2 multiplied by f2. That's what we mean by the principle of moments. That's the formula that applies there. Okay, let's say we've been given some values here. Let's say this is a meter that starts from 0 up to 100 centimeters. And then they say this object which is at the end here is 50 kg. And then the pivot, let's say it has been placed on the 20 centimeter mark. And then this object here has got 20 kg like that. Now the question is, okay, now here we even know just everything. Let's say we don't know the mass of this one. They've just told us this is m. We want to find what mass we are going to put at this end for us to be able to balance this ruler. So to be able to determine that, we're going to use the principle of moments. F1 multiplied by D1 is given by F2 multiplied by D2. So there will be a force going down here. And how do we find force? Force is just given as the mass multiplied by gravity. And there will also be a force down here. Okay, now let me not write Fmg, but I'll just write force. And then let me put a 2 there. This will also be a force here down as force 1. So if I get this force 1, now I don't know this force 1. So I'm just say force 1 multiplied by the distance away from the pivot. What's the distance? So this object has been placed at 0. Okay, and then the pivot is at 20 centimeters. So the distance from 0 to 20 is 20 centimeters. But we need to make sure that the distance is in the SI units. But it's okay even if it is in centimeters like that. So we're going to put 20 centimeters here. This should be equal to the force. Now that should be force. Here we've been given 50 kg. Kg is not force, that is mass. Force is given by mass multiplied by gravity. So the mass here is 50, gravity that's 10. So 50 times 10, it is going to give us 500. Now it's going to be newtons. So we're going to get this as the force, 500 newtons, multiplied by the distance, that's the second distance, the distance from the pivot to where the mass is. So you can see that the mass is at the very far end, that is what, 100 centimeters, and then this one is at what, 20 centimeters. So I'm going to say from 20 to 100, what's the distance? Okay, so 100 minus 20, what are we going to get? That is going to give us 80, and this one is in centimeters. Remember, I want to remain with F1. So we're going to divide both sides by 20 centimeters. Also this side by 20 centimeters. So the centimeter will cancel with this centimeter. Even here, this will cancel with this one. So this will give us F1 being equal to this 0 will cancel with this 0. And then these two can go into 8 4 times. So if we get 4 multiplied by 5, that is going to give us a 20. But remember, also have two zeros there. So that will be 2000 newtons. But the question is, we want to find this mass, not the weight. How do you find mass? We know that force, which is weight, is given by mass times gravity. And the weight we've been given as what? We've calculated the weight or the force as 2000 newtons. It should be equal to mass, which we don't know, times gravity. Gravity is 10. So divide both sides by 10. And this will give us a mass of, this 0 cancels with this, so this is going to be 200 kg. So if this ruler is supposed to be balanced, we need to use a mass of 200 kg at this point. So this is one application that we can use when we're talking about moments of a force. At times you can be asked to find the mass of a ruler when you are working with moments. And how do you get to find the mass of a ruler or the weight of a ruler? So let's say you've been given again an object. First, a ruler. This is a 1 meter rule. Okay, and then we put a pivot at this point. So since this is a 1 meter rule, if they've told us this is a 1 meter rule, we should be able to know what that means. It's a 1 meter rule. And then let's say the pivot has been put on the 20 centimeter mark. And then at this point, let's say this is on the 5 centimeter mark. We have put an object that has got a mass of 20 kg. Now the question is, find A, the mass of the ruler, and then B, the weight of the ruler. So how are we able to find the mass and the weight of the ruler? To be able to do that, the weight of something, if this, we are assuming this is a uniform meter ruler. What we mean by uniform is that the mass is distributed equally and this ruler is uniform. It doesn't go like this. Okay, if this ruler is uniform, meaning that the mass of this ruler is concentrated on its middle. So if this is a 1 meter rule, 1 meter we can convert that to centimeters, that is 100 centimeters. If this is a 1 meter rule, then the half of this ruler on the middle of this ruler is at what mark? Correct. That is on the 50 centimeters, because starting from here up to the end, that is 100 centimeters, because in 1 meter I've got 100 centimeters. So the middle of this ruler is going to be at 50 centimeters, and that is where the mass of the ruler or the weight of the ruler is concentrated. So it is this weight of the ruler that is going to be balancing this ruler such that it doesn't fall this direction or it doesn't fall in that direction. So we're going to still use the principle of moment. F1 multiplied by D1 is going to be equal to F2 multiplied by D2. Now F1, we're going to take this one as the first. We need to find the force. We've been given the mass. How do you find force? So force is given by mass multiplied by gravity. So the mass is 20 kg, gravity is 10. So 20 times 10, that is going to be 200. Always use the weight, please. So we are going to put 200 here, newtons. Now what's the distance? The distance, we can see we've placed this one on a 5 centimeter mark, and then the pivot is at 20 centimeters. So you need to find the distance where you've placed your object from the pivot. So that is going to be 20 minus 5. What are we going to find? That is going to be 15 centimeters. And this should be equal to the second force. The second force is the weight. That is what is balancing the roller from falling. And then the second distance, it is from the pivot to the middle. Okay, so that will be 50 minus 20, which is a 30 centimeters. Then we want to remain with W, so we're going to divide both sides by 30 centimeters. Centimeters and the 30 will cancel, centimeter will cancel the centimeter. 15 can go into 32 times, and then these two can go into 20. That's 10 times, but this is a 200, so it will go there 100 times, and the newton has remained. So 100 newton is going to be equal to weight. So this is the weight of the ruler. We have answered the second part of the question. Now to answer the first question, we know that weight is given by mass multiplied by gravity. Weight is what? 100, and that is going to be equal to mass. What is the mass? We don't know. That's what we want to find. And then G is 10. So to find the mass, divide both sides by a 10. So the mass therefore is going to be, this cancels with that, this cancels with this. So this is going to give us 10 kg. Make sure that every time you're working with this, you are working with SI units. It's very, very important. You should be working with SI units. If you're not working with SI units, you'll not be able to find the correct thing. Okay. Just like you can see, when I'm making calculations, every time I'm finding the answer, I'm finding it in what? In kg, because I'm dealing with what? Newtons. Well, the SI unit for length is not centimeter, it is meter. But even if you can notice, I'm not using the meters. Why? Because I have a centimeter this side, I also have a centimeter this side. So because I'm dealing with centimeters both sides, they're going to be able to cancel out. That is why I'm just going direct. If both of them cancels out, I'll still remain with the newtons which I want. Because if I've got a centimeter on one side of the equation and a centimeter on the other side, these two are able to cancel out. Okay. Otherwise, whenever you're dealing with newtons as the unit for weight, when you find the mass, it will always be in kg. It will never be in grams. Alright, let's see. We've been given another question. Okay. Let's say we have a question like this, like that. We have got the pivot at this point, and we've placed, let's say, an object at this position, and still let's write a condition. Given a 50 kg ruler, 50 kg is very big. Let me use grams because that wouldn't make sense. Given a 50 gram ruler, 50 gram, I should also state a 1 meter ruler. So we've been given all the conditions. Okay, and then let's say this object, as we've said already, it is 1 centimeter. Now the pivot has been pressed on the 20 centimeter mark again. Should I always use 20? It might confuse someone. No, it will not always be given as 20. This is just a question that I'm constructing. So here we are given like that, and then we have got this object which is 25 kg. Okay, now the question is find the position of the 25 kg mass from the beginning of the ruler. So how are we able to calculate that? What to be the position from the beginning of the ruler? What to be the distance? So to be able to determine that, if this ruler, an assumption we are taking is it is in equilibrium, the ruler is in equilibrium, meaning that it is not moving, it is balanced. And to be able to do that, if we see this ruler is just balanced by itself, but we've not placed anything this side, meaning that what has balanced this ruler on this side is the weight of the ruler, and the weight of the ruler is always on the middle. We are always taking that this is a what? This is a uniform ruler. So at this point here, we are going to have the weight, and this mark should be the 50 centimeters. And the weight of the ruler is given by mass times gravity. Now let me just say weight. And then this object here is also going to have a weight because it has got a mass. Okay, so we need to know the distance where this object is from the what? From the position of the pivot. And so we need to know this distance here. Let me call it d1. Okay, that's d1. And then we also need to know this distance from the pivot to where the weight of the ruler is. Let's call it d2. From the principle of moments, d1 mod f1 d1 should be equal to f2 d2. Now f1, we've been given 25. So to find f1, f1 is given by mass times gravity. F1 mass is 25, gravity is 10. So this is going to give us 250 newtons. Whenever you're using the mass should always be in kgs. Okay, so we're going to put 250 here newtons multiplied by the distance 1. We don't know that distance. Well, let me just call it d1, and that should be equal to f2. What is f2? We've been given f2, that's the weight of the ruler. Now we've been given the mass of the ruler is 50 grams, so we need to find the weight. Okay, so weight is given by mass multiplied by gravity. Now the mass, remember, should be in kgs, but we've been given in what? In grams. How do you convert it to kgs? We know that in 1 kg we have got 1000 grams. So we're going to put the grams here. 50 grams is equal to x. So I multiply x times 1000, that is going to be 1000x. 1 times 50, that is going to be 50. Divide both sides by 1000. So this 0 cancel with this 0. So x is going to be 100 into 5. It is going to be 0.05. Okay, 0.05. This is now in kg. I put it at the wrong position. Okay, so now that's the mass 0.05. We now multiply by the gravity to be able to determine the weight. So weight is 0.05 multiplied by gravity, which is a 10. So when I'm multiplying by the 10, the decimal point will just move once, and so the weight is going to be 0.5 newtons. That is what we're going to put here, 0.5 newtons multiplied by the distance. Now the distance, we've got 20 centimeters to 50, so just a 50 minus 20, that is going to be 30 centimeters. Okay, and then we want to remain with d1. We're going to divide both sides. Of course, this one is in newtons. We're going to divide both sides by 250 newtons, also this side by 250 newtons. This term is going to cancel with this term, and from here this newton here is going to cancel with this newton here. So we're going to remain with d1 being equal to, we're going to multiply 0.5 by 30, and then the answer that we are going to get, we'll divide it by 250. So this is giving us 0.06, and look, this is in centimeters, that's a unit, so this is going to be 0.06 centimeters. Okay, so this means that this distance is very, very small, like this object is very, very near to what, to 20 centimeters. Now remember, the question is saying find the position of the 25 kg from the beginning of the ruler. So the beginning of the ruler is here. Okay, so if we know the distance from the beginning up to the pivot, this is 20 centimeters. And then we've also found the distance from the object to the pivot, that is what, 0.06 centimeters. Now we want to find the distance from the beginning of the ruler to where the object is. What will this be? So if we add this distance x with this 0.06, we should be able to get the total distance from the beginning of the ruler to the pivot. So we'll say x plus 0.06 should be equal to 20. We'll take the 0.06 the other side, so x is going to be 20 minus 0.06. So that will give us x being equal to what? Let's say 20 minus 0.06. That is going to give us 19.94 centimeters. So this is the distance of the object from the beginning of the ruler, and that is how you get to work out moments of forces. So the only thing that you should be able to understand is we need to know the principle of moments. If we just know the principle of moments, any operation that we are going to be given to work out, we are going to be able to what, to answer it. Okay, let's look at another question. We see how we're able to work it out. So we've been given an object like this, and at this one position you've got something like that. Well, these are held at this point strongly, and at the end here we have got an object. Let's say there is a bucket there at the end. Okay, and then the distance that we've been given from the end here up to where this pole is, that is 0.3 meters. Okay, and then also the distance from here up to the very end there, that is also given as 1.5 meters. Now the weight of this object is given as 1 kg. That's its mass, 1 kg. Now the question is, what force is going to balance this object? What force is going to balance this beam at this very end, such that this will not be able to fall, or it is going to be in equilibrium, it will not be able to move, it just be straight like that. So what force is supposed to be at the end there? So to be able to find that force, we use the same formula. F1 D1 should be equal to F2 D2. So F1, this is the force that we have here. Clockwise moment should be equal to anti-clockwise moment. D1, this is the distance, because that's 1.5. This is in meters. So if this is in meters, this should also be in meters. There shouldn't be in different units. And then F2, we've been given this as 1 kg. We need to use the weight and not the mass. Weight is mass times gravity. So this will be 1 multiplied by 10, which is what? 10 newtons. So this is going to be 10 newtons. And then multiplied by the other distance, which is 0.3 meters. So to remain with F1, we'll divide both sides by 1.5 meters. Also this side by 1.5 meters. Okay. So let's see what we get. First multiply 10 by 0.3, that is going to give us a 3. And then 3 divided by 1.5, that is a 2. So we are saying that F1 is going to be 2. The meter and the meter is cancelling, so the answer is going to be in newtons. So the operations here are not hard. All we just need to understand is, how do you work with principle of moments? Do we know the equation that apply when we are talking about principle of moments? That is one thing that is just important. If we just get to understand that, any type of question that you might be given is not going to be any cumbersome. Okay, and let's look at a last question. Here we understand how to work it out, and then we'll be good. Let's say this is a rule and we've got a pivot at this point. We have got an object here, and then we have got another mass, which is another weight at this point. And let's say we also have an object here. Okay, now what we are taking here is, whenever you are dealing with moments of forces in the equation. Okay, before I even talk about that, let's say this object is 50 kg, this one is 20 kg, this object which is suspended here is 10 kg, this one is, let me increase this one like that. This is the 1 meter rule. And we are going to take it as massless. We are going to understand the importance of taking it as massless. Alright, and then the position, the distance from the end here up to this point. See, this is 5 centimeters. Then we know the position also from this end up to the very end of the ruler there. Okay, let's say that distance we've been given is 30 centimeters, like that. And then we don't know this distance from here up to here. Let's say they have said this is x. Then the distance from this end is 5 centimeters. Now the question is, find x. So that's the question. We want to find x. So how are we able to find that? And then we're going to add another one, find the clockwise moment. Okay, starting with the first one, if you want to find x, we need to look at all the clockwise moments. They should be equal to the anti-clockwise moments. So all the moments going in this direction should be equal to all the moments which are going in this direction, because this ruler is what is balanced. So to be able to do that, let's first look at the moments in this direction. That is going to be F1 multiplied by D1. This should be equal to all the moments in this direction. So we're going to take this one as M1. or as f2, and then this will be f3. This is going to be f1. Now here we have got two forces. These two forces, if we multiply this distance, so let's call it d2, we multiply by f2, it should be equal plus the other distance, this distance here from the pivot to where that other mass is. Okay, that will call it d3 and then multiply by f3. So the distance from here up to where the object is multiplied by this force should be equal to the distance from here multiplied by this force plus the distance from here multiplied by this force. Those are what we need to understand. So clockwise moments should be equal to anti-clockwise moments. Now, starting from the pivot, here we have got two masses. So we're going to have a force going down here and then another force going down there. But here we only have one force coming down. So F1, this object is 50 kg. To find the weight is just given by mass times gravity. So gravity is 10. Just multiply this one by a 10. So that is going to be 500. So this is going to be 500 multiplied by distance 1. Now what distance? What is this distance? This distance is from the pivot. So where the mass is from the pivot. Okay, like that. I even forgot to say one thing. This object has been placed on the 20 centimeter mark. This is 20 centimeter. So if this is a 1 meter rule, okay, this is a 1 meter rule, and the distance from this point up to the end of the ruler, actually I didn't even need to give this 20. Okay, all we know is we know the distance from this point to the what? To the end of the ruler. That is 30. And we know that this is a 1 meter rule. We know 1 meter is the same as 100 centimeters, right? So if this is a 1 meter rule, the distance from here up to the end is a 30. What will be the distance from here up to the very end here? Let's see what we're going to get. Yes, that's correct. That is going to be 70. So the distance from here up to this point is going to be 70. That is because if we add the distance from this point up to the end here plus the distance from this point up to the end there, it should give us what? It should give us 100 centimeters, which is the same as 1 meter. So we're going to multiply by the distance, which is 70 centimeters. And this should be equal to d2. d2 is what? This is x because f2 is is this one. So we are going to say d2 is x. But what of f2? We know the weight, the mass, I mean, that's 20 kg. Convert to weight, that is going to be 200 newtons. Okay. And then plus d3, the distance from this point up to this point here, what will that be? Now if we know the distance starting from the pivot up to the end of the ruler is 30 centimeters, and then from the end of the ruler up to this point is 5 centimeters, what will be this distance? Let's see, what are you going to get? That's correct, that's 25 centimeters. So all you do is subtract 30 minus 5, and then you find the distance from here up to where the pivot is. So that is going to be 25 centimeters multiplied by f3, that is given as 10. So 10 multiplied by 10, because we want to find the weight. Weight is mass times gravity. The mass is 10 kg, gravity is 10, so that is going to be 100 newtons. So from this point we're going to make sure that we get to add like terms together. Remember, this 500 is also in newtons. So we'll say 500 times 75 times 7, that is a 35. So this is going to be 35. We have got 2 zeros plus this one, those are going to be 3 zeros. So that will be 35,000. This is Newton centimeter. So this is going to be Newton centimeter. And this is going to be equal to x multiplied by 200 newtons. And then plus, multiply 25 centimeters by 100, that is going to be 2,500. This is a Newton centimeter. And then we'll take this term the other side here because they're like terms. So 3,500, I mean 35,000 Newton centimeter minus 2,500 Newton centimeter, and that is going to be equal to x 200 newtons. So we're going to subtract 3,500. I mean 35,000. This is 35,000 minus 2,500. That is going to give us 32,500 Newton centimeter, and that is going to be x 200 newtons. So to remain with x, divide both sides by 200 newtons. So this will cancel with this. So x is going to be equal to, the newton is going to cancel with the newton. So 32,500 divided by 200. That is going to give us 162.5. The unit which has remained is what? Is a centimeter. Correct. So that is it for this question. So the distance x here is going to be 162.5 centimeters, though this is a made up question, and so you can see that it doesn't mathematically make sense. And what's the reason of it not making sense? This cannot be 162 centimeter. We can't have an answer 162 because this meter only ends at what? It only ends at 100 centimeters, but this is more than 100 centimeters. This tells us that the only way this ruler can be balanced is if this object is placed far away at the end of this ruler. That's the only way it can balance, because if you multiply 50 by the 70, which is here, the moment is going to be far more greater than the moments this side. So that's the meaning of this. Otherwise, that's how to go about it, but the answer itself is mathematically incorrect from the statement that we've been given in this question. All right. Now, when you want to find the clockwise moment, just this portion here, that gives us the clockwise moments. So we'll find the answer as 162.5 centimeters. So that means that this ruler cannot be a 1 meter ruler, unless maybe a 2 meters ruler, not a 1 meters ruler. So clockwise moment, clockwise is going in this direction. So we're going to get this distance to multiply by this weight. So that is distance 2 multiplied by force 2, and then we're going to get distance 3 multiplied by force 3. That will give us a clockwise, the clockwise moments. Distance 2, of course, we found 162.5 centimeters. Now, whenever we're finding moments, make sure that the answer is in Newton meter. So we need to make sure that this distance is in meters. So we need to convert that to meters. And how do we do that? We know that in 1 meter we have got 100 centimeters. So we're going to say 162.5 centimeters is equal to x. So multiply x by 100, that will be 100x. Multiply 1 by 162.5, and then divide both sides by 100. So the answer is going to be 1.625. So that will be the distance that we are going to use, 1.625 meters, multiplied by the force 2. The force, we saw 20 multiplied by 10. We want to avoid, because this is mass, it is going to be 200. That is in newtons now. And then plus distance 3, that's the distance from this point up to this point. We saw that was 25. Now again, convert 25, because it's in centimeters, to meters. Just divided by 100, that is going to be 0.25. Then multiply by the weight or the force, that is 10 kg, but we wanted 10 newtons. So 10 times 10, that is going to be 100 newtons. Okay, so we'll start by saying 1.625 multiplied by 200, that is given as 325. This is going to be Newton meter, and then plus 0.25 multiplied by 100, that is going to be 25 Newton meter. This one is in meters. So now we're going to add this 325 plus 25. So this is going to give us 350 Newton meter. So this is the anti-clockwise I mean the clockwise moment, taking the ruler in this direction. Well, that marks the end of this tutorial. Thank you so much for watching. Stay blessed.